Hello railroad friends. It's a beautiful day here in May in Attleboro, Massachusetts in 2020, the year of the dumpster fire. And yeah, I should be working on bench work, but you know what they say, all bench work and no play makes Jack a dull boy. So I thought I would have some fun with the laws of physics, specifically friction. As some of you may know, I have a Pennsylvania K4 live steam locomotive, and it's a puller, but I have very, very tight curves. What you're looking at here is my main line, and it has I think a minimum radius of just over 7 feet on the inner track, which is actually technically the return track for my dog mode. And that's a little tight for Aristo heavyweights. If I left the stock wheels on, the flanges would lock up and there'd be 100% flange drag. However, I've switched them out for Kadee, and the Kadee wheels do a very nice job of keeping some slip, but there's still a lot of flange drag around the curve. So I said, well, what can I do to eliminate it? And so I want to show you what I've done, and then I'm going to give you some experimental evidence to demonstrate what worked. So sit tight, enjoy the ride. This is a standard Aristocraft heavyweight. It has 6-wheel trucks. The trucks all have Kadee wheels, aftermarket wheels. And we're going to send it downstream and see how far it goes. I'm going to give this thing a pretty good push. And let's see how far she goes. Not too bad. And as you can see, that's the tightest part of the curve right there, and that's where all the flanges lock up. All right, let's reset the experiment with our next candidate. Okay, so this is candidate 2. In addition to replacing the wheels with Kadee wheel sets, which give me much better flanges, what I've done is I have ground down the flanges on the middle axles of both of these trucks. So what we have now is a blind set of wheels in the middle here. The idea being that now the inner flange won't bind against the inside rail on the curve, which will force the outside flanges to also bind. So this should give us the opportunity to let the car find its natural middle on the track, and we should get slightly better performance. So here we go. I'm going to give this one a pretty good push. And that is a downhill grade. And you can see that after it does make it through the tight spot, and it continues to go for a little while. So overall, I'd say that's a huge improvement just by providing some blind wheels on the middle of these wheel sets. I'm going to go get her and we're going to try it again. So overall, really not bad performance. I'd say that's an upgrade. That's definitely going to help hauling cars. Stand by though, because there's one more trick I got up my sleeve. All right, our final candidate here is going to be a further improvement. So we've taken the stock Aristo wheels off. We've replaced them with Kadee wheels. Now they are a little smaller. They're not quite the 33-inch to scale, but I think the trade-off in terms of performance is worth it. I mean, maybe someday I'll cut my own wheels using their profile. You know, you have to have a metal lathe to do that, but we'll stick with them for now. I have also included the blind axles on the middles of this car, just like the last test. So we already know we're going to get very good performance. However, in addition, I have installed ball bearings on all 1, 2, 3, 4, 5, 6 axles here. Yeah, I had to count that. And honestly, the performance is just, it's out of this world. So here we go. We now have pretty much the least frictionless heavyweight you can possibly get using Aristocraft stuff. And here we go. All right, I think that's probably good enough. Let me go get that one. For those of you keeping score and say, well, Rick, you didn't give that guy the same level of push as the other ones, I think you can understand why I didn't have to. I'm going to try and just barely get this thing moving and show you like how wonderfully smooth this thing is down a small grade. Thank you, gravity. Not bad. So I think we'll be putting bearings on all of these. I do have some concerns about braking, but you know, that K4 is a pretty heavy beast. I think it weighs in close to 60 pounds when it's full of water. And it does stay still on level track. It's just pretty much impossible to park them on anything that's above 0.5% grade. I think it's really worth it. The bearings I used, I'll try and find the link for it, but they are 1/8 inch internal diameter, 1/4 inch external diameter, and they have flanges on them so that I could figure out when they're flush. They weren't too expensive. They came in pairs. I think I bought them from like Servo City or one of those robotics setups, and yeah, overall, I'm very, very impressed with that. I think that's going to help me pull. I think if I equip cars appropriately, I could probably pull 12. No problem. Anyway, hope you found it entertaining, and I'll chat at you later.